Okay, so yesterday we did graphs of linear rational functions, which really can be described as shifts from 1 over x, the reciprocal function. So now we're saying, well, we got harder functions. So we're looking vertical, horizontal asymptotes, predict end behavior, and really be able to graph. Okay, and I know it might not necessarily be you're graphing everything, but you got to be able to answer anything that I ask. So if you look at this, shifts aren't going to work because it's not linear. You got a square, and if you got a square anywhere, you can't do it. Now, you could do in your calculator, and you Desmos, whatever, and you could get that picture. Um, now, what are some things you see about that picture? Well, there's no x-intercepts or zeros. There's one y-intercept. There's no vertical asymptotes, but it does seem like it's not a horizontal asymptote. What if I asked you to do that by hand? So when I talk about these things, that's really what we need to be able to find by hand. So this is listed in the notes, but it's a attachment. But we're looking at things that can't be done with shifts. So first thing you should always do, reduce it to lowest terms. Now, really, what is that doing? Factoring, if possible. Can you factor anything on the top and the bottom? Because if you have a common factor, that is going to be a whole. Step 2. Determine the location of any vertical asymptotes or holes in the graph if they exist. Well, how do you find your vertical asymptotes? Vertical asymptotes, set the denominator equal to 0. Those are your vertical asymptotes unless you have a common factor. Then that number would be a whole as opposed to an asymptote. So you want to think, how do I find these things? How do I find vertical asymptotes? Set the denominator equal to 0. Now we need end behavior asymptote. Now notice it doesn't say horizontal. It could be horizontal, but it could also be a parabola, a cubic, whatever. So what you do to figure out your end behavior asymptote, which could be a horizontal asymptote, is you look at the degrees. If the degree of the top is less than the degree of the bottom, and you just have to memorize this, it's y equals 0. Now, what would that be? Something like 4 over x squared plus 2. The degree of the top is 0. Even if I had 4x, the degree of the top is 1. The degree of the top, remember degree is highest exponent. If the degree of the top is less than the degree of the bottom, y equals 0. If the degree of the top equals the degree of the bottom, it's horizontal. Y equals the leading coefficient of the top divided by the leading coefficient of the bottom. So something of that sort would be like 3x cubed over 2x cubed minus 1. The degree of the top is 3. The degree of the bottom is 3. So it's a horizontal asymptote, leading coefficient divided by leading coefficient. Y equals 3 over 2. If the degree of the top is greater than the degree of the bottom, that would be something like 4x squared minus 2 over x plus 3. That's a 2. That's a 1. You do not have a horizontal asymptote. You have y equals a polynomial function. It could be y equals mx plus b. It could be y equals x squared. It could be y equals x cubed, etc. It's found by dividing the top by the bottom. And however many degrees the top is bigger than the bottom is really telling you, is it a line? Is it a quadratic? Is it a cube? Like you could see with this is a 2, that's a 1. It's 1 degree larger, so it's going to be linear. 2 degrees larger, it would be a quadratic, etc. So, vertical asymptote, bottom equal to 0. End behavior asymptote. I look at the degrees. They could be horizontal or it could be a polynomial. Next thing, find the x and y intercepts. X-intercepts, zeros of numerator. What does that really mean? Set the numerator equal to 0 and solve. To find the x-intercepts, top equal to 0. To find your vertical asymptotes, bottom equal to 0. To find your y-intercept, value of f of 0. Y-intercept is the value of y when x is 0. So really you want to think, plug in 0 for x. So then you go in, if you're asked to graph it. Now lots of times I'm just going to ask you for information and you have to be able to find these things. So you sketch the asymptotes, you sketch any points that you had, and then any additional points as needed to sketch the graph of the function. So, you know, the thing is you can't think Desmos. Because if I say, hey, how do you find your vertical asymptotes? You got to know, set the denominator equal to 0. How do you find your y-intercept? Put 0 in for x. How do you find your end behavior asymptote? Look at the degrees. So you have to memorize how to do this stuff. So I'm just going to sort of do a couple and say, okay, what if I asked you to graph this? Okay. I'm going to actually, I guess if I just said, hey, find your asymptotes first, just to get used to finding the asymptotes. Vertical asymptote. Set the bottom equal to 0. X equals 5. End behavior. Could be horizontal. The degree of the top is bigger than the bottom. It's not horizontal. I have to take the top and divide by the bottom. Now again, people always freak out. It's long division, but it's 2 steps. So what do you multiply x by to get x squared? X. Distribute x squared minus 5x. Subtract 2 minus negative 5 is 7. You can drop that, but it really doesn't matter. What do you multiply x by to get 7x? 7. You stop. The remainder has nothing to do with the function. That is y equals x plus 7. So your end behavior asymptote would be y equals x plus 7, which I'll do one so you can see that. So this, how would I find my vertical? Set the bottom equal to 0. Now, you can't factor that. You're like, I can't factor that. Do the quadratic formula. Opposite of b, plus or minus b squared minus 4 times 3 times 6 all over 2 times 3. Well, that's like 49 minus 72. It's a negative. 49 minus 72, something like negative 23. There are none. That never equals 0 because that's imaginary. Can't happen. Okay? End behavior asymptote. Look at their degrees. They're equal. When they're equal, I take the leading coefficient divided by the leading coefficient. Y equals 8/3. So you just have to know that information. So I ask you to graph. I'm going to do 2 here to start, and then I'll sort of make another video where I do another one. So I'm supposed to do everything here and draw it. So I try to help a little bit. I'll be like vertical asymptote, end behavior asymptote, x-intercept, y-intercept, and that at least helps. So you think, first thing you're supposed to do is factor. Well, if this is like x minus 3, x plus 2, there is no common factor, so there's no whole. So vertical asymptote, I'm supposed to set the bottom equal to 0. I already factored. I actually have 2 vertical asymptotes. X equals 3, x equals negative 2. Okay? And I could go and just sort of as I go, negative 2, 3. End behavior asymptote. Well, I look at degrees. Top less than bottom. That's horizontal, y equals 0. Now, what that means is way out at the ends. So I don't do the middle. I leave the middle open because you can cross the middle. My end behavior asymptote is y equals 0. So, did that. X-intercept, I gotta remember, x-intercept is set the top equal to 0. I set the top equal to 0. Now remember, this is a point. This is the value of x when y is 0. It's not an asymptote. So you would get x equals 1. What that means is it crosses the x-axis at 1. Y-intercept, I'm supposed to put 0 in for x. Well, I do that on the top and the bottom. So it would be like 0 minus 1 over 0 squared minus 0 minus 6. Well, that gives me negative 1 over negative 6, which is 1/6. So I know I have another dot there. Now, where's the graph going? This is where you would have to make a table because there's 2 things that can happen over here, and I'm going to get rid of them after I draw them. You either got something here or here, but you don't know which one. So in order to find which one, you're going to have to put in negative 3. Well, if you put negative 3 in the function, on the top, that would be negative 4. On the bottom, that would be 9 plus 3, which would be 12 minus 6, negative 2/3. Okay? It can't cross those dashed lines and you don't have a 0. So that gives you that part. Same thing over here. It's either here or here. Well, how do you figure it out? Put in 4. Well, if you put 4 in the top, you get 3. If you put 4 in the bottom, 16 minus 4 is 12 minus 6 is 6. So you get 0.5. So that means it's got to be there. In the middle, this has to go that way because it can't cross through the x-axis anymore. Now here, it could go up or it could go down. So you would have to put 2 in. If you put 2 in, on the top, 2 minus 1 is 1. On the bottom, 4 minus 2 minus 6, that's like negative 8. So it's down there. So it has to be that. So you're using your head a little bit, but you did all of that without technology. Okay? And you have to be able to explain how you got it. So if I did this, actually I want to do one where it's bigger than the bottom. So let's say I gave you this one, x cubed over x squared minus 9. Again, I'm going to give you vertical asymptote, end behavior asymptote, x-intercepts, y-intercepts. So vertical asymptote, set the bottom equal to 0. Solve it, factor it. I mean, that one you can solve plus or minus 3. Those are lines, plus or minus 3. So I know on my graph, I got positive 3, negative 3. End behavior, the top is bigger than the bottom. So I got to divide. X cubed divided by x squared minus 9. What do you multiply x squared by to get x cubed? X. That gives you x cubed minus 9x. When you subtract, you get 9x. That's a remainder. You don't care about the remainder. Your end behavior asymptote is y equals x. Well, that's a diagonal line. So it has a slope of 1, a y-intercept of 0. So you got to think you're going up 1 over 1, up 1 over 1. And if I draw that, my end behavior asymptote is a slanted line. X-intercept, set the top equal to 0. The value of x when y is 0. Well, x cubed equals 0. You think that that's 0, but it is actually an intercept. And then the y-intercept, the value, if you plugged 0 in, you'd get 0 over negative 9, which is 0. Okay, so you sort of have this idea, which really means that it doesn't cross the x-axis. Now this one is a weird one. When you're looking over here, and this is the part that is hard for people to understand, something happens to the left of negative 3. You have two choices, this or this. Well, it can't be the top one because it can't cross through the x-axis. So it has to be something down there. Same thing to the right of 3. It's either here or there. It can't cross through there. So that means it has to be up there. with here, you either got to get something like there or there. So if you put in like really 1 point, like if you did 1, you'd get 1 cubed divided by 1 minus 9 is -8. So you got a negative. So that has to be down there and not that. So that's a start. At least that can get you started on looking at these.